Alright, so what we're going to look at is what happens when you mix lithium aluminum hydride with an ester. And if you remember, lithium aluminum hydride is a really strong reducing agent. So we're going to convert this to an alcohol here on the left, cleave this bond, and turn this into an alcohol. Alright, so let's draw it out and then we'll talk about it. So keep the carbon chain. We'll add an alcohol. Alright, and this alcohol here was this oxygen. Alright, now the portion on the right, so this becomes its own alcohol because we're going to cleave this bond. Alright, so that's the bond we're going to cleave. And then this oxygen up on top was this oxygen because we added two hydrogens here from our lithium aluminum hydride. Alright, so what we end up doing is we cleave the ester bond, right, which is this bond here, and we turn this into an alcohol, and then since we cleave this bond, this leaves as an alcohol as well. Alright, and so that's why we get this OH. Alright, and this hydrogen comes from our water molecule. Alright, let's look at another one, a little bit more unique. Same idea, right? We're going to cleave this bond. Alright, so we're going to break that bond. So let me just redraw it the way it would look. So we're going to keep that carbon chain. And I'm going to leave it in kind of this cyclohexane shape. The oxygen here on the right is going to turn into an OH. So let's just do that. And now the oxygen up on top, right, so that was part of our carbonyl, also becomes an alcohol. So let's draw that in. And what we've done is, remember, the hydrogens are going to come from lithium aluminum hydride. So we'll put our hydrogens in here. And then remember that this hydrogens and the water are the ones that donate these hydrogens at the end of the molecule. Right, once it's done with the workup. And so what we've gotten here is we've made this carbon group that goes across the backbone is going to keep them tethered, right? Because we didn't break any of these bonds in the back, that's why they're still linked together. And then the other way we could draw this out is if we number these. We have 5 carbons. And then off carbon 1 there's an alcohol. And then off carbon 5 there's an alcohol. And so these two molecules are actually the same, right? This is the same compound as this. Essentially what we've done is just stretch this out. Alright, so when you see lithium aluminum hydride, what it's going to do is cleave an ester. The carbonyl is going to turn into an OH, and the portion that left is going to turn into an alcohol. Alright, so in the case that we did above, if it's just a normal straight chain compound, we're going to actually get two products, right? We get the alcohol that came from the carbonyl portion, and we get the alcohol that came from the oxygen portion of the ester. If it's in a ring, we can still have one compound because it's tethered through that backside. But you're still turning the carbonyl into an alcohol, and then that other portion that gets cleaved also turns into an alcohol.